Welcome to Ms. Parb's Flipped Classroom. In this lesson we're going to talk about the quadratic formula and the discriminant. The objective is to use the quadratic formula to solve quadratic equations and also to use the discriminant to find the number of solutions for a quadratic function. The quadratic formula. This is something important you'll need to write down in your notes. If ax squared plus bx plus c equals 0 and a is not equal to 0, then the quadratic formula is x equals a negative b plus or minus the square root of the quantity b squared minus 4ac, all divided by 2a. And the a, the b, and the c in the quadratic formula will come from your a, b, and c in your quadratic equation written in standard form. Okay, the quadratic formula can be used to find the solutions to any quadratic equation. So far you've learned how to use square roots, you've learned how to graph, and you've learned how to factor. Some of those work some of the time, but not all of the time. The quadratic formula will always work. You have to make sure though that the equation is written in standard form, which means it's equal to 0. So always check that before you start. So in this example, written in standard form, the answer is yes because it's equal to 0. Our next step is to identify the values of a, b, and c. A is your coefficient of x squared, so a is 2. B is the coefficient of x, so b is 3. And c is the constant, which is the number by itself, so c is a negative 5. Okay, after we've identified the values for those, we want to substitute those into the quadratic formula. So I rewrote the quadratic formula. And now wherever we see a b, we're going to put 3. Wherever we see a, we're going to put the number 2. And wherever we see a c, we'll put negative 5. So here's the quadratic formula. Here are our values substituted in. And then the last step is to simplify this substituted quadratic formula. Okay, start with what's under the radical sign, because if you try to work this problem all at once, it's really easy to make a mistake. So 3 squared is 9. So we have 9. A negative 4 times 2 is a negative 8, and a negative 8 times a negative 5 gives us a positive 40. When we add those together, we get 49, which is where this 49 came from. We just simplified what was under the radical sign. So now we have a negative 3 plus or minus the square root of 49 divided by 4. Okay, this plus or minus means that we're going to have two problems to work. We're going to have one to work where we add and one to work where we subtract. So we took a negative 3 plus the square root of 49 is 7. So we have a negative 3 plus 7. When we add those we get 4. And then we divide by 4 to give us 1. A division bar is like a grouping symbol. So that means we have to do this addition step before we do the division. The second part of this, we said we had to subtract, so we take a negative 3 minus the square root of 49 is 7 divided by 4. We said this is a grouping symbol, so we have to do this step first. Negative 3 minus 7 is a negative 10 divided by 4 gives you a negative 2.5. So for this quadratic equation, the two solutions are 1 and a negative 2.5. So if you plugged either one of those numbers into x, you would get a value of 0. Okay, here's another example. In this example, we have x squared minus 8 equals 2x. This is not equal to 0. So the first thing we have to do is rewrite it in standard form. So we subtract 2x from both sides, which means this cancels, leaving us a 0. We had x squared minus 2x minus 8. Write down the values of a, b, and c, 1, negative 2, and negative 8. Write down the quadratic formula, substitute these values in, and then simplify. And just like before, we're going to simplify what's under the radical first. A negative 2 squared means a negative 2 times a negative 2, so that would be 4. A negative 4 times 1 is a negative 4 times a negative 8 would give us a positive 32. And when we add those together, we get 36. which is where this 36 came from. So now this problem has simplified to 2 plus or minus the square root of 36 over 2. The square root of 36 is 6. So now we have x is 2 plus or minus 6 divided by 2. So once again we have our two problems, one where we add, one where we subtract. 2 plus 6 is 8, divided by 2 is 4. 2 minus 6 is a negative 4, divided by 2 gives you a negative 2. So the solutions to this quadratic equation are negative 2 and 4, which means if you graph this, that's where your parabola would cross the x-axis. Okay, the discriminant we're just going to talk about briefly. It's the portion of the quadratic formula under the radical. It's the part I've written here in red. This is the discriminant. And I also wrote it over here again. The discriminant is b squared minus 4ac. And whenever it's greater than 0, which means it's positive, you have two real solutions. When it's equal to 0, you have one real solution. And if it's less than 0, meaning it's negative, you have no real solutions. This does not tell you the solution. It only tells you how many solutions you would have. How many times your graph either crosses or touches the x-axis. So in this example, how many solutions does this quadratic equation have? X squared minus 6x plus 7 equals 0. And this also has to be written in standard form, so always check that first. So a is 1, b is negative 6, c is 7. We substitute those into the discriminant, which is b squared minus 4ac. So we have a negative 6 squared, which gives us 36, minus 4 times 1 times 7, which is 28. 36 minus 28 gives us 8, which is a positive number. So just like it told us over here in our table, we have two real solutions because this was a positive number. We don't know what those solutions are, but we know if we figured it out, there would be two solutions.